Good morning or afternoon, whenever you guys are seeing this video. We are in week 8 for algebra lesson 5.3, interpreting rate of change and slope. This is going to be a short lesson for this week. Hopefully you guys already know how to do most of this, but we do have to go over it in a way that maybe might hopefully seems familiar to you, but we still have to go over it in this class. So the vocabulary we're going to focus on for this week is very simple, just rate of change. What is rate of change? In this case, the rate of change is a ratio or a fraction that compares the change in variable y to the change in variable x. So what does that mean exactly? Well, the rate of change is found by the following formula: change in y over change in x. Now, this seems like it seems that it should be a little bit straightforward, but really what we're doing here is we're deriving a different formula that we've actually already used in the past. So the whole point of this week is to dive deeper into slope and slope formula. But in order for us to be able to understand slope formula, we need to understand how things change from one point to another, and that is what we're going to be focusing on. Okay, so without further ado, let's move on to this. Now, the question I have here, I have some background information, right? The cost of stamps at the post office is organized in the table below by cost and year. So, in the post office, every year they're selling stamps, and every year they have to increase the price of stamps, or they usually try to, because, everything costs more every year. So, the price of stamps usually reflects this change in price every year. In the table I have here, the information's already been organized for you. It says years after 2000, and I put X. The 3 in this case would mean that where that 3 is, right? Where this is 2003. This would be 2004, and then you just kind of fill in there. The X value in this case tells you what year this is, and the cost below is how many cents it costs to buy a stamp in that year. Okay. What we're trying to find out, our question here is to find the rate of change for each time period using the table. In other words, we want to know, okay, from what year to what, from 2003 to 2004, what was the change in price, right? Now, by just looking at the table, you should be able to see that from 2003 and 2004, there really wasn't any change. They were both 37 cents by the end of it. So, I mean, that was it, right? Well, we're using the formula from before. So remember this formula here, the change in y over the change in x? This is what I actually mean. This is what it looks like here. So we're right here, right? So from 2003 to 2004, we start with the change in y. Now, remember, this is my x value right here, and this is my y value. The y value for the year 2004 is 37, and I want to find out the change, so I'm going to subtract whatever stamps cost in the year 2003, which happens to be 37. If you notice, I'm going to put the change in y on the bottom as well. Now, if you notice, I put 2004 in front of 2003, even though the problem says from 2008 to 2004. The reason why I did this was to avoid a negative number as part of my answer. Yes, you can have negatives as your answer, but in the context of this real world problem, um, the price didn't go down. Negative in the real world in terms of money implies that you either lost money or that the price of something goes down. That's not what's going on here. From 37 to 37, right? Nothing changed. So if you notice here, 37 minus 37 is 0, and 4 minus 3 is positive 1. That makes sense because there's been no change in what appears to be 1 year, right? But if I were to do it the other way, if I were to put 3 in front of 4, I would end up getting a minus 1. And even though the answer would still be 0, I would be saying that there's no change uh, in a negative year, and that doesn't make any sense. So you do have to put the larger number first, generally speaking, and this is going to be This is going to be important for the slope formula that we're going to work on later. This is kind of the basis of why we put x2 and y2 in the first spot instead of what you would argue could be the other way around. Right. So here, anyways, long story short, right, we end up with 0/1 and 0 cents. So in other words, from the year 2003, 2004, there's been a 0 cents change per year. In other words, nothing changed. In those 2 years, the price was the same. It was 37 cents. Right. It might seem like a really long-winded way of saying that, but it's okay because this is a very simple example. When the examples get a little bit more complicated, that's when this method helps you understand it much better. Okay, so the next thing is from 2004 to 2006, right? We have, let's see, the values change because there is a change here. So we're gonna start in 2006, right? And our X value for 2006 is 6. So I'm gonna put 6 on the bottom here. That's where I got this from, right? And I'm gonna put 2 on the bottom. Sorry, I made a mistake. That should be 4 because I'm actually looking at 2004. And 2004, the X value is 4. So 6 minus 4 would give me a 2 as my denominator. And 39 minus 37 is going to give me a 2 in the numerator. So the difference between the first and the second version of this is, if you notice, there's a 1 in the denominator in the first problem, and then there's a 2 in the denominator. So what that means is, even though our answers are going to be different, there's a different number of years to take into consideration, right? So from here, we're saying that there is a change of 2 cents in 2 years. And if we reduce that, 2 divided by 2, we end up getting 1/1, which is just 1. In other words, every year there was, in between 2004 and 2006, there was a 1 cent increase every year, right? Now, the fact that the numbers are positive suggests that it goes up. That's why it's an increase, right? In reality, usually we don't put the plus, but I'm going to put the plus here just so you know that's what I'm referring to, right? Every year from 2004 to 2006, the price went up by 1 penny. Okay. What about from 2006 to 2008? There's still a 2-year difference between them, right? Just like the previous problem. Was there a major change? Well, again, we're going to start with the X value. That 8 is what we put on the bottom here, right? And the 6 from the 2006, right? Okay. And then from goes on the bottom here, right? Because again, we're referencing the change in X and the change in Y. The X values go on the bottom on the denominator and the Y values go on top. Now the Y value is 42 this time, minus 39, which gives me 3. That gives me this top part right here. And the bottom 6, 8 minus 2 is 8 minus 6 is 2. And I have 3/2. If I divide in the calculator 3 divided by 2, I end up with 1.5. That means that from 2006 to 2008, the change was, instead of going up by 1 penny every year it went up by 1.5 pennies, right? Now, this is an average rate of change. Because you might be thinking, well, how can you pay half a penny in the real world? Well, you kind of can't. So what that says to me is, without more information, I can reasonably conclude that maybe it went up 1 cent one year and 2 cents the next year, which would make a total of a 3-cent increase. But because it happened over a 2-year span, right, the average change per year is 1.5. And do you guys see that there's a difference between that? It might be confusing, and that's fine. I might make it seem like it's more confusing than it actually is. I do apologize for that if that's what's happening, but just try to follow along, and so hopefully it gets a little bit more clear towards the end. The last part, from 2013 to 2008, that should be reversed, right? It should be from 2008 to 2013, but really that's what the numbers are saying. So here, my X value is again up here. It's 13, which means that 13 goes on the bottom. Remember, all X values go on the bottom on the denominator. So from 2013, I have an X value of 13, right? So 13 goes on the bottom minus the x value for 2008, which is 8 in this case. So 13 minus 8 gives me 5. That is in my denominator, right? Check. And now I just have to I have to put my y value. So 46 is my y value for the year 2013, right? So that would make it 46 minus 42, which is 4. That is a 4, right? Okay, so 4 divided by 5 actually equals to 0.8 cents change per year. Now, from 2013 to 2008, there is a 5-year difference, right? So in 5 years is different. If this whole thing, if there was a perfect linear progression from 2003 to 2013, right? Like we're used to seeing, like just a straight line that we can predict, everything should have gone up. The price should have gone up by the same amount every year, right? But that's not what we're seeing is that's not what happened here. This graph suggests that instead of the graph that we're going to see, if we were to graph this, right, instead of it being like a graph that looks like that, what we're actually seeing is it goes up like this, like this, like this, like this, maybe like this. This is the kind of graph that we're going to be seeing because if you notice, every single year, right, there's a different rate of change, meaning that from every single point from every single year that we're measuring, there's a different slope, right? So this brings to the idea that slope is really measured between just 2 points. If those 2 points happen to be at the beginning and the end of a line, great. That entire line is what we call linear, and that's what you guys have been doing in the past couple weeks. But what we're going to be doing now is a little bit different because there's more points, right? Right there, all of a sudden, there isn't just one massive slope for one big line. There's a bunch of little slopes that make up one really jagged line, and that's what we're doing. All right. So, what kind of questions are you going to encounter this week? Well, the key question here is how do we measure rate of change between two coordinate points? Remember, I just said you're going to be focusing on two coordinate points, and we have to use the slope formula, which has its root in what we just did, right? Slope formula is up there. Make sure to write the slope formula down. By the way, another word for slope is just the letter M. And I know you guys have seen this in the past because we've used point slope formula, which is pretty much related to this. Slope is just trying to figure out what M is, right? So you guys have seen this before. Now we're focusing a little bit more on what just M means, right? Also, if you notice here, I have y2 minus y1, x2 minus x1. These are referring to two different coordinate points, and you are the one who decides which one is x1, y1, and which one is x2 and y2, right? So typically speaking, when we're doing one of these, right, and we have 2 points, right, this has its own set of coordinate points, and this one has its own set of coordinate points, right? This is just in case you didn't know. Now, this is x1 and y1, right? This, if that's x1 and y1, this would be x2 and y2. Now, I can switch these around. I can make the other one be x1, y1, and then the first one be x2 and y2. As long as you keep those ones and twos together on the same coordinate point, it doesn't matter. So what do I mean by that? Okay, you're going to be given 2 coordinate points. You're going to be either given a graph or you're going to be given 2 coordinate points like I have in my example down in the second half of this. In this case, I gave you 2 coordinate points, -5, comma 2, and 5, comma 3. What is M? In other words, what is the slope? What do you need to do? Use the slope formula that I just gave you to try to figure that out. All right, so down here I have M, because remember, M is a variable that represents slope. Instead of writing slope every single time, I can just put M, and that's what that means. M is equal to y2 minus y1 over x2 minus x1. So now I have to decide which one's x1 and which one's y1 and x2 and y2. I'm just going to make the first one be x1 and y1, and I'm going to make the second coordinate point presented to me be my x2 and my y2. Like I said, you get to choose which one is which one. As long as the ones are together and the twos are together on the same coordinate point, I can flip them around and I would honestly get the same answer, right? So here I just picked one. I just made the first one I saw x1, y1, and the second one I saw x2, y2. Now I'm going to plug them in. So in this case, my y2 is 3, is right here. So I put 3 on top. Minus my y1, which is 2, I put 2. Then I put my fraction. Then I put my x2, which is positive 5, minus, and see here I have a negative, right? So if you notice, I put the second 5, the minus 5 in parentheses, and I kept the negative, right? I can't just put a regular 5 in there because that's not going to accurately represent what's going on. If x1 is negative 5, I need to include the negative 5 as part of the number, right? X1 is not 5, it's negative 5. Therefore, that this minus sign that you see right here, that minus sign, that original minus sign is part of the equation. But this minus sign is part of the coordinate point, right? So therefore, there's two subtraction signs next to each other. And if there's two subtraction signs next to each other, they become positive, right? So really what's going on is 3 minus 2 is equal to 1 over, and then 5 plus 5 is equal to 10. My slope is 1 over 10. And 1 over 10, if I were to graph this, right, and you can see I kind of made a small graph there. 1 represents my rise, meaning I start at negative 5, 2, which is right here. I don't know if you guys can see it. That means that negative 5 means I went to the left, so I started here. I went to the left, I went 1, 2, 3, 4, 5. Then I went up 2, 1, 2 to get there. That's where my starting point is. So from that point, I rose 1. So I rose 1, right? And then I went to the right. I ran 10. So that's why if you count all those little bubbles that I wrote, right? I moved 10 spaces to the right, and I ended up with my final point here, which actually happens to be my second point here, because this is 1, 2, 3, 4, 5, positive 5, and up 1, let's see, 1, 2, 3, up 3. So I start off at my first point, and then in my second point, there's my line. I have graphed it, and that's what you will be expected to do. You're gonna see either, I'm gonna give you either graphs, and you're gonna have to like figure out what the coordinate point is for each one of them, like I just did, and then use those coordinate points, put them into a slope formula, and then tell me what it is. Or you're going to be given 2 coordinate points without the graph, and you're going to be asked to graph them, right? These are all skills that you need to do for this week. Another thing that you need to do is you need to label them, right? So after using the slope formula to find the slope of a line between 2 coordinate points, you need to label what type of graph or what type of line everything is, right? What kind of slope it is. There's different kinds of slope. So for example, in the first example right here, let me go ahead and label them 1, 2, 3, and 4. There's 4 examples of the 4 different types of slope. When you guys finish finding the slope, like I did in the last one, you also, as part of your answer, I want to see you write, this is a positive slope, this is a negative slope, this is a 0 slope, or this is an undefined slope, right? And this is how you identify them. If you're graphing them, right, if they give you the graph, you should just be able to straight up see what direction they're going. So if the graph looks like any of these, right, that they give you, you know which one it's going to be. If, however, they ask you, hey, can you graph this, right, you're going to have to make the graphs, and then if they end up looking like any one of these, you'll know which one it is, right? You can figure this out in one of 2 ways, right? If you had to use the slope formula, like for example here, I noticed that this fraction is positive, right? Therefore, without even graphing it, I already know because my m value, remember my m, is a positive number, and yes, my fraction was positive, my graph is going to look like this. It's going to look something like that, okay? That means that if my m value is positive, then I'm going to end up with a positive slope. And I would write right here that this is a positive slope. M is equal to plus, and if you notice I put an n, right? That just means number, right? Whatever the number is. In this case, the number is 110, so this would be positive 1 over 10. Now the second one, if I had ended up with a negative for whatever reason, my answer isn't wrong. It just means that my answer needs to be interpreted a certain way. When it comes to like money, a negative slope would indicate that I lost a bunch of money or that something cost me a lot, right? Um, but negative typically doesn't mean the opposite of positive. It doesn't always mean that. So just be very careful about what that means. In this case, the negative slope, it just means that my m, whatever it came up with, if there was a negative in front of it, it's going to start off really high and then it's going to kind of come down, right? The third kind is a straight line. What happens if I just get a straight line that goes all the way to the right, and there's 2 points, right? Like there's a point here and there's a point here, right? And I end up with 0. Well, if you end up with 0, you end up with what we call just a horizontal line, right? Horizontal lines have 0 slope. You're allowed to have 0 as an answer to your slope, right? All that means is that it's a straight line, right? It's not going up, it's not going down, it's just going straight to the right. And there's nothing wrong with that. That's a function. 4, however, is not. Now, if you look at 4, if I have 2, right? If I have 2 points like this, mathematically what ends up happening is if you did the whole this, and you ended up with something like a number divided by 0. In math, you can't really divide by 0. Because just think about what that means in the real world. You have a number, and you're going to divide it by nothing. You might be tempted to say, well, isn't the answer nothing? Isn't the answer 0, right? No, the fact is you can't actually do that problem. Because how can you divide an amount of something? Let's say you have like 10 apples. How can you divide 10 apples by nothing? You still have those 10 apples, right? Even if you try to divide it by nothing, if you did nothing to those apples, 10 apples are still there. 10 divided by 0 doesn't give me 10. It also doesn't give me 0 because the apple still exists. Therefore, it's a problem that I can't really do, right? And if I can't do the problem, if I can't do that division problem, I don't have an answer. That is what we call an undefined slope. Now that line is what we call a vertical line, right? It goes straight up and down. This one's a vertical line. This one's a horizontal line, right? Now the vertical line just goes straight up and there is an undefined slope. You can't calculate the slope. And is there a way to calculate the slope? Technically, yes, but we're not going to focus on that. For the purpose of this lesson, I want you to label it as undefined, okay? Okay, so this week is very vocabulary heavy, and it's a deeper dive into something that you've already done and added a little bit something extra. Here's what I want you guys to do. Homework and practice is problems numbers 1 through 14 is due 5, 24, 20. And yeah, if you have any questions, please join me for my Zoom office hours, 1:30 to 3 p.m. Monday through Thursday. Okay, so if you have any questions, please contact me there. Even if you don't have any questions, check in at least once a week so I know that you're alive. And um, and hopefully everything's going well. And shout out to all the people who have birthdays this month or have birthdays throughout this quarantine. It hasn't been easy on anyone, but hopefully if you do have a birthday or you have a special day coming up, take time and do something, right? Have a great week, and I look forward to your questions.